power of 6. So you 32 minus 6 you have, you cannot see here. Why? So fast. Save energy, I think, save lens. So 2 power 6, so you know that this is 2 power 6 actually will produce at least 64, right? This actually will produce 64. So 32 minus 6, I'll have like a 26. So see, idea actually for the one actually slash 26. Okay, if you look at the table here, okay, just want you to understand better. Okay, so 26 means here. Okay, 26 just not 26. What do we got? 26, right? Okay, mask length 26. So this means the subnet mask actually 255, 255, 255, 192. Why 192? You know why 192? Faham tak? Siapa yang terfaham pasal apa 192 kat sini? Because here, you see here, this actually will be based on, what is this, the last binary mask. So here you have like, what is this, 26 means here you will have 11111, correct or not? 8, 8, 16, 24, 8, 16, 24, another 2 bit you use from the last 8 bit, another 2 bit to get the 26. Faham tak? 11111. I just quickly write now. 8. Then like this. Then like this. Then like this. Okay, this is actually the subnet mask. So this is the 192 mentioned here. Okay, this is subnet mask. This is 255. Okay. Later, Isha is not try to observe the table, because if they ask the subnet mask, you know what you're supposed to do. Okay, because you're very good in finding the 26. After that, they ask subnet mask, you don't know, but actually it is there. Correct or not? Then it's like wasting the marks. But you won't have this one in your exam. But with the 26, you should supposed to know that, okay, until when actually you'll get this one, then you should know. Okay, you see after more than what is this? After more than 25, more than 25, it will go to the second octet. Third octet, sorry. This is actually fourth octet. This is actually 1, 2, 3, 4th. At fourth octet, the subnet mask actually changed. But when it goes to the more than 25, then it will start from the second octet. So here you will keep it 0, only here the number actually will change for masking, subnet masking. Okay, this is actually subnet mask actually. This number is actually called subnet mask because there is calculation for you to find the particular IP address based on the subnet mask. We didn't go, because we are actually going on the design part, I didn't go to that one. We don't have enough time, okay? I don't want to confuse more. Now actually we only focus on the designing, okay? But designing and additional info like this, you should know what is that. Okay, come back to this. So 26. And then the second one is actually 2 power of 5, I think. So you should at least have 32 to accommodate the 25. So this will produce 32 minus 5, 27. So slash 27. Ni berapa? 2 power 4 enough, right? 2 power 4. 32 minus 4. 28. So you have to slash 28. And the last one? 2 power 1. 2 power 1, right? So here you have 31. No need to waste time. Okay? Yeah, better write lah then. You tell me you didn't write, that's why I don't know. Okay. Now, determine the subnet mask and locate the required subnets. So how much? Okay, let's say we do in like your friend said just now. Okay, your friend said just now. I mean, better we wait first. Like friend said or okay, fixed length. We use fixed length for all of them. Okay, fixed length for all of them. So we will find the maximum actually how much here from here? 50. Okay. So we are going to create the subnet mask. I think just now we actually calculate the FLSM actually in the wrong way. Okay. Actually we have to still need to provide the subnet mask for each of them with the address. So the waste actually will more than what we expected just now. Just now the wastage is lesser actually because we still use one address, not like that. Okay, because under that you will have like lot of subnet mask. Ignore the FLSM that we calculated just now, this is the right way. Okay, so now determine the subnet mask for each of the mask means we have to usually for FLSM, the case of FLSM, you'll check the highest or largest number of hosts. Okay, so we fix based on this and then we still create for each of the department, but we will fix based on this highest number. Okay, we won't actually do like variable means for each of the hosts we find the variable, the n value actually different. Okay, but for FLSM we only will choose the highest and based on that we will create the other subnet. Okay, so let's say n is actually 6, right? So all of them actually will be 6. We're not actually going to vary the value. Okay, that's actually how we will do. Understand? So, and this is actually for FLSM. I think better I write this one here. Boleh ya? Macam boleh. Apa saya boleh datang sekali? Only this one cannot. It's supposed to. Oh, this is the word, not picture. Cannot edit a mistake here. Okay. Otherwise you'll get confused. Have to part out. Then we have to get this one. This is for VLSM. Because after 1 week or before exam you'll check this one, you'll get confused, correct? So we do again for just quickly. For 50 is 2 power of 6, right? 32, sorry, 64. 2 power of 64. So 32 minus 6, you will have 26, so slash 26. The next number is what? 25. I'm just writing again because I don't want it to write on the FLSM side, then you'll get confused. This is actually 2 power of 5, 32, so 32 minus 5, I'll have 27 slash 27. This is for A, this is for B, C is actually how much? 10, 2 power 4 is actually 16, so 32 minus this 4 here, 28, so slash 28. The last one, WAN, right? Yeah, WAN. 2 power of 1. So 32 minus this one here, and have 31, so slash 31. This is for BLSM, okay? Just, I don't want to get confused. This one clear, right? Okay. For FLSM, we will go for the highest, and from the highest, we get one slash, right? So we will keep on repeating using the same slash, but for different network. So how much here the highest? 2 power of 6. Okay, so for all of them it will be 6 only. Okay, so all of them actually will be 6 only. So we actually, for example, let's say for here, the highest number is 6, right? Where is it? Oh yeah, 2 power 6. So for all of them, you'll use slash 20. How much is 26? Just now. Slash 26 slash 26. We won't actually what to call 1, 2, 3, 4. Yeah. For all of them, you use slash 26. Just that later when you do the table, here the address actually will be different from them. So 26 means here how much? 64, right? So you have to be careful with the number 64. So regardless, okay, this network we use like a 50. So here we will have like a wastage of 14, and here we will have a wastage of how much on this one? 64 minus 25. How much? 30? 39, right? And here we have like 54. Here we have like a 62. So this is actually how you will calculate. Okay. We use fixed. When the fixed actually we take from the largest. We cannot take from the lowest because then lowest actually cannot support the largest, right? So we use the largest, and then we keep repeat for the other network. So here you'll have like a lot of wastage. Okay. And the same thing, if you keep repeat for what is this, for here, how much are total here? Let me know. 14 plus 39 plus 54 plus 62. 169. Okay, and here 64 minus 50 is 14. Here 32 minus 25 is 7. 6. Here 0. So how much here? 27. 27. Oh, yeah, 27. Okay. We won't actually, just now I told you right, from here we actually will get the whole node. We still actually will assign as a subnet for each of them, but we take from the largest value. Okay. Okay, when they for example, let's say they ask subnet mask right here. Okay, when they ask the subnet mask, then you have to for each of the network you have to be careful, because subnet mask actually, like what I told you just now, you should write like a 25 25, that like the table given here. It's a table. So for each network means this here we have a 26, 27, 28, 31. So 26 here. Okay, 26, 27, right? So like this. So you have to get to know the bit value for each of them and calculate the what is that? This is the binary mask for each of them. So you have to calculate the decimal value for each of them. So 255, 255, 255, then 0.224 you have to write like that. So for example, let's say here, subnet for each network. So for the first case, I do for the first case, then you do for the others. 26, right? 26, right? So I will have 255. This is 8 bit, correct? Another 255. This is another 8 bit, 255. So here altogether I have 24. So the last 8 bit I need to have another 1. Okay, then the rest of them like this. This is actually we require only 2 bits from here. So total this one you will get the 26. Okay, total this one will get the 26. But this is the subnet mask for this particular network A. Okay, subnet mask. So when you write in this one in decimal, what is the value for decimal? If you forgot what is the decimal, just can use the calculator, change this one to decimal. How much? If you use calculator, because exam you won't remember. How much? 192. Because just we refer to the table, that's why I remember. Otherwise, I also use the calculator. This is for network A. You can try for the other network. Actually, you write like this, also consider subnet mask. People will understand, okay, this is actually the... When you write like this, it is already correct, but also learn to write like this. Okay. In exam, let's say most of you do like a graph, at least you write like this, I'll give marks. But if all actually said that not going to happen, all of them become suddenly good. Okay. But you know now you do this one, but in exam you can leave it until here. Okay. Because once you write the CID, the what to call that mask, ideally people will understand, networking people will understand that, okay, this is the way of 255, 255. The last bit, this actually shows the last bit actually of that form. Okay. Okay.